Hello everybody, my name is Mark Spevick, and in this video I'll be showing you the basics of using some more advanced techniques to build in some creative control to this simple Hollywood style destruction scene. Let's dive into Houdini and have a look. So here we are with the scene of the car going through the brick wall. Now the kind of control I want is the ability for the to direct the shapes and the overall impact look of the car going through the wall. So how might we do that? Well, first of things I'd like to change and get more sophisticated control of is the way that the wall is actually pinned to the world. Let's go into our dot network for a minute and talk about what I mean by it. See what I mean by that. Now, if we just look at the anatomy of a dot network very quickly, we have the object nodes feeding to a solver. There's the static branch, and we have our rigid body feeding to its own solver in its branch in this merge, and they merge together here so they interact with each other. And then they're fed into the gravity so the forces affect them. And then down here we have our constraints, or our glues if you like, and you can tell by the names what they are. This is the glue to the wall to itself, and this is the ground plane to the wall. And it's the ground plane to the wall that I have a slight issue with. At the moment everything is simulating, and it's not the most sophisticated thing, because often in a big building you don't want everything simulating. You just want the point of impact to be simulating, because that way it's cheaper and quicker. So this is not the best method, so for that reason I'm going to delete these nodes. I'm going to come up one and delete this node down the bottom here, glue ground plane to wall. This is the constraint network. We don't need those anymore. If I press play though, on the other hand, when the car hits the wall it's going to take the whole wall out with it, unfortunately, which is not quite the effect we're after. There we go. So how can we get more control over this? Well, let's have a look at one of the very useful concept in Houdini, and that's the ability to use attributes and SOPs to affect things in DOPs. Let's have a look at what I mean. Let's have a look first of all at our rigid body object here, the wall. Now there's an attribute that I'm interested in. If we look down in the spreadsheet here, here's our wall object. If we open this up and scroll down a little, we can see the geometry. If I select on the geometry, we can look at the different geometry attributes. Now it's a point attribute I'm interested in, and it's this one here called active. At the moment that's set to 1, which is true, and that's because the initial object type here is set to create active. If I set this to static, if we look at our static objects, that's the things like the ground and the car. These are objects that don't simulate, but will be there to interact with other simulated objects. And you'll notice the active parameter here is set to 0, and as a result nothing happens. Our wall doesn't interact with the car there. I apologise for the ghosting, that's because we have it up here. Let me turn that off. That's a bit clearer to see. If I change this back to an active object, you'll see that parameter set back to 1, and now all our bricks are active objects and they'll react to the forces. So by knowing this, we can manipulate that attribute in SOPs. In fact, we can manipulate any of the attributes we see here in SOPs, as long as they're the same type. This is a point attribute, so let's manipulate those point attributes. Now I need to go to my wall network, so if I go up one and just dive inside the wall network, we can see that a few nodes have been added after the wall geometry here. This left hand side is the geometry that goes to the network, and this right hand side is the glue. We'll come back to this one in a minute. Now let me just separate these out. This node here is preparing the geometry for the simulation, and this node here is sending it to the sim and bringing it back. Let's have a look at this for a minute. What's interesting is if we click on the information here, you'll see we only have 1,982 points, and there's more than 1,982 points in that wall. That's because this is a packed primitive. I can display to you what a packed primitive actually looks like here with the display as flag. I set this to centroid. Let's turn that on for a minute. You can see this is actually what a packed primitive is, a bunch of points that relate to the geometry that we're dealing with. Let's set this back to full geometry so it's not so confusing. Now if you look, here are the point attributes, and we just need to create one here. So an easy way to create one is with the attribute create node. So if you tab attribute create and make that node, let's turn this on. I'm going to call this attribute active, as we saw, and it was an integer. It's a whole number, so we make sure it's a point attribute and that it's an integer, and look, a value of 0, and look, there it is on the geometry. If we go back to our simulation, we will see it's now at 0 here, even though we've told it to be active. If I press play, nothing happens when our car hits that wall. And there we go, nothing simulates. Whereas if I go back one, if I click on this little arrow here, I'll go back a folder. I can set this value to 1, it's now true. If I go back to the sim, that's also a 1 here. If I press play now, our wall is active and things will move. So knowing this, we can use some SOP techniques to vary that active attribute over the wall and get the desired effect that we want. Now this is useful because anything that is passive or not active is not simulating, so it's very, very cheap and much quicker to process that. If this was, say for example, this was part of a massive building, most of it would be passive and the bit you're interested in would be the only bit active. So how can we specify which small part of this wants to be active and the rest passive? Well, there's many ways in Houdini, but one of the easiest ones is to make a group. Let's make a group node, drop that in after this attribute create node, turn this on, and you can see the group is selecting everything, it's highlighted them all yellow. If we set this to points, because ultimately we're dealing with points, you'll see it all goes green instead. I'm going to rename this group to active, and if I click on the information, you'll see that we have a point group called active, and there's 1982 points in it. In fact, all of our points in it are in it. That's because we've got a base group turned on here. Let's turn it off. It's no longer green. Now, one of the interesting ways that we can select a group is to turn on bounding regions, and then we have a bounding box. Now, with this node selected, if you click on the special manipulator or hit enter, you'll be able to resize the bounding box interactively. And as you can see, the ones that are green are actually in the group called active. And I'm just leaving the ones on the outer frame passive there. Or, sorry, not in the group. So how can we use this? Well, we need a copy of the attribute create node to put afterwards. Now at the moment, that value, if we go to this first one, I'm going to set it to value of 0. So they're all passive. We've got our group node, and then this second one, I'm going to set value to 1. And the problem is, it set them all to 1. Now all nodes in Houdini, or most nodes in Houdini, have at the top a group parameter here. Now this is so that you can make a selection of objects using a group, and then this node will only affect the objects within that group, but if you specify the group up here only. Click on the drop down, we can see our active group there. If I click on that, we now see that if we scroll down through this list, that some of these guys have a 1 if they're in the group, and the 0 if they're not. So there's a, let's see if that worked. I click back to the dot network here and press play. We'll see that the car hits the wall, but the wall doesn't go anywhere this time because it's glued to the outer frames. Those ones are basically all passive now. Now there's an advantage to doing this. The reason I wanted that to stay in place and be glued to there. In fact, actually, there's a different way to do this. Let me show you a slightly different way. We're going to ultimately create the same thing, but we're going to do it slightly more in a more sophisticated manner. Because at the moment we had to create a node to define the active attribute, created a group to define the points we wanted in it, and then another node just to change the attribute on the objects in the group. We can do this with one less node using a wrangle node. I'm just going to make a copy of the group so we've got selected the points that we want to make active, and I'm going to make a wrangle node, a point wrangle node because we're dealing with point attributes. Let's plug that in instead. And we can actually make the attribute with code. We know it's an integer, so we can put an I for integer, at, so we know it's an attribute, and we type active, and let's set that to 0. Now as soon as I hit enter, we'll see that we get our attribute here called active, and it's set to 0. If we set this to 1, click away, we'll see the value changes to 1. So how do I make it work with the group? It does have a group parameter, but actually we can call the group directly here in the wrangle. You'll notice that the, let's put a value in, that the group, there's an attribute here called group :active. So we can refer to that. Now to refer to an attribute, we can call it its type, an integer, at, and we can see it's called group. Now we don't put the colon in here, we put an underscore instead, and we call it active. Now if we look through our attributes here, we can see that where active is 1, it's in the group, and where it's 0, it's not in the group. So that's having the same effect as before, and this time, oh, let me just turn that node on and off. If we press play now, we'll see it looks exactly the same as the outer ones are passive, they're glued in place, and then the active ones in the middle are all attached to those. A slightly more sophisticated way of controlling geometry in DOPS is through the use of SOP attributes. Now we can play with the glue constraint for a minute here. We can play with the strength, but that's not ultimately what the interesting one. This just either stops it breaking in some areas or others. The one that's more interesting, I find, is actually this propagation iterations. What this means is, let's have a look at the glue network and talk about that. So if we just look at what the glue network looks like, you'll see it's a bunch of primitives. And these primitives, let's click on the primitive tab. If we select this node, have a bunch of attributes here. So that's interesting. On the geometry of the pack primitives are points, we're using point attributes, and on the constraints they're primitives, so we're using primitive attributes. And we can see there's a bunch of them here. Now each one of these is joining together our bricks for us. And if you imagine the propagation iterations, if this bond breaks, he's just going to break. If I put up the propagation iterations, what that means is if he breaks, he's going to take his neighbour with him. And the more higher the iterations are, the more you're allowing further and further neighbours to break if a bond is broken. Let's have a look at that in practice. So back in the DOP network here, we've only been allowing one bond to break. Let's put something like 20 in. So when one of these glue bonds breaks where the car hits, we're going to allow up to 20 of its neighbours to be taken with it. And as a result, we'll see the gap of where the car impacts is a bit wider as things fall apart a bit further away here. So you get this nice thing of the impact and then some of the bricks falling away. If we actually put this up too high, something like 50, you'll see it's a large area and probably the whole wall would collapse. But if you remember, we've pinned it around the outer edges by saying that they're all passive. So they won't ever simulate. Let's see how far this goes. There we go, going right to the edge on the left hand side here. You can see the ones we said passive aren't collapsing. So this is quite good. We've got the car going through the wall and most of it collapsing, but what I'd like to do is build some control in now to say where I want some of this to collapse and where I don't. And again, we can do that through attributes driven through SOPs. And as I mentioned before, that we're going to do that through this the glue constraints, which are primitives. If I hold my cursor over here, we can see this parameter is called strength. So where can we add that attribute? So let's go back to our wall and let's have a look at our constraint network. Let's come up here to this constraint adjacent pieces. This node here is actually creating this network. So what I'd like to do is create an attribute called strength, but I'd like to be able to paint where I'd like stuff. So let's use the paint node first. So hit tab and type paint for the paint SOP. Let's drop that in and turn it on. So this is going to allow us to paint a color attribute on the points, not the primitives, but that's fine for the minute. Now we have a foreground and background color. I'm going to make the foreground color 100, so it's unbreakable. It's going to be now this is actually a multiplier for what's inside SOPs, inside DOPs. So this is going to be 100 times the default strength, so that's going to be unbreakable. And the background color, I'm going to make a very small number, like again 100th. So whatever we have will be 100th of the strength. So this should be very, very weak to break. Now we can hit apply all, which makes everything very weak, and clicking on the let's just leave that at that for the minute and jump back to this. Oh, let's leave that for the minute and see if this works. Now at the moment this is a color attribute. If I click on the points here, we'll see it's a CD in the points, but there's nothing in the primitives. I need it to be a primitive attribute. I need it to be called strength. The easiest thing to do is to promote this attribute from a point to a primitive. So let's hit tab and type attribute promote. Here, first of all, we select the attribute here, color. It's a point attribute. We want to convert it to a primitive. And look, now it appears on the primitive tab here. If we scroll through, we can see our very low values. Next, I want to rename it to strength. So that's easily done. We can use an attribute create node. And remember, this is called strength. Let's spell it correctly. Oh, not in uppercase. Strength. Make sure it's a primitive attribute, and it's a float, and we'll give it a value. So we want to read the color red, the color. So this is a float, a one value, not a vector. So we need to refer to either the color of red, green, or blue channel. And we can refer to an attribute like we saw in the wrangle before with an at, capital C, small d for CD, and then a dot R. You could put dot G or B, but since it's black and white, it will all be the same value. When I hit enter now, we'll see that the strength is inheriting the value of the red channel here. Now again, we didn't have to do that with an attribute create. We could do that with a wrangle node. So this time we want a primitive wrangle because we're making a primitive attribute. And again, if we select that, we can say f at strength. Oh, let me spell that right. Strength equals at cd.r. There we go, and it's exactly the same result as we had before. Let's see the effect of that if I go into the DOP-sim. Now how do we know if this value is coming in? Well, like we did before, we can find the geometry in the spreadsheet. So that's not under the wall. It's actually under relationships. If we open that up, we'll see our glue constraint network here. If we open this up, there's no geometry, but it's in the constraint network. If we open that one up, there's our geometry. Now we're looking at primitives, so let's click on the primitive tab, and there's our attributes, and there's our strength coming through. So it's coming through if we press play. So this is 100th, so this is about 100 in strength there, and it's several thousand in strength around the edge. It's not actually, because everything was very weak. You see the whole wall's basically collapsing. Got very weak glue all the way around, and everything's just propagating to the edges there. So that's good. That means the zero is working. Now I'm going to paint where it's solid. So let's go back to the wall, click on the paint node, and I'm going to paint in the foreground color here. So I'm going to hit enter. I can use shift to make my brush bigger, and I'm going to choose where I paint is not going to collapse. So we don't want this bit to collapse around the wall like this. In fact, I want to change that. I can click on the background color and middle mouse button draw. That will paint that off a bit. There we go. And then let's left click. If you hold down shift, you can make your brush a bit bigger. And I'm just going to paint some interesting shapes. Move that bit like that. Something like this maybe. There we go. Let's see how that might work. Now let's press play. Now that strength will multiply by these values here. We should see something hopefully a bit interesting. And you see it collapses away where it's a value of 0, but where I've painted the value of 1, it stayed solid. So we see these little bits sticking out that I've painted. We see this up right here. Let's have a look. That I wanted to stay up, staying up. So managed to direct the look through the painting of the attributes there. Looking at it, there's one thing I'm not happy with. Even though I have the upright sticking up here as I wanted, we can see the car intersecting on the left here. I'm just going to go back to the painting of the wall just to fix that. So let's select the wall network, turn on the paint node, and I'm going to just paint off this area here using the background color again. So with a middle click I can just paint that down so that'll break on impact with the car. And actually while I'm here, let's create another bit of interest. I'm going to click on the foreground color. Actually, let's just paint this up a little bit more. But by clicking on the foreground color, I'm just going to paint a patch here. This is going to keep this or prevent this from falling apart, and but around it's going to break as well. So it's going to fall out hopefully in an interesting shape. And let's leave a little bit sticking out over here as well. So if I click on the little back arrow, it'll take me back to the last part of the Houdini I was in. and let's see the effect of that. Now, hopefully this is going to smash the bricks here and not intersect, which was ugly, but also we're going to see a piece up here that's going to stay together. And if we have a look, we can see they're permanently glued because the glue is very strong. And over here is that little bit that we painted sticking out. So a lot more control. We can get bits stick together and have bits not break at all and get much more interesting shapes at the point of impact there. Now I just want to improve the fidelity of the sim. If you have a look at the point of impact, it's quite sudden. With all simulations, it's sub-steps that are important. My wall's not displaying correctly. Let me just dive in the wall network and turn back on the DOP import, which will bring back the correct geometry. But yes, the fidelity of simulations is all about time steps, how quickly you're calculating every second for. So we're calculating every frame, but this car obviously is going quite fast and hits between frames. So I'm just going to increase the number of sub-steps up here to 2. It'll make the simulation go a little bit slower, but ultimately it will give us slightly more accurate collisions and more accurate impacts and things like that. So let me just play that through. You'll see we get a much nicer initial impact here. If I just stop that for a sec, rather than all exploding out at quite a distance, we're getting this much softer sort of breakthrough before we see them explode out. And then as our car carries on breaking through, we can see the bricks breaking apart around the sections that we painted. And it will give you a slightly different result here. You can see the force is not propagating enough and breaking off our panel. In fact, is that going to break away? Not quite yet in this one. I could paint a bit more there to weaken it up a little bit. But the substeps has made it go that little bit nicer. Let me just pop back to the wall network once more and see if I can just weaken that for one last time. So let me get the background color up. Just paint a bit more of a gap here so it's more likely to fall out. Let's turn back on the DOP import node, back to the DOP network. And let's see if that has the effect we want. And if that is, I'm quite happy with that. The next stage comes to is to cache it out and save it to disk. So let's see if we get a nice impact here with the extra substeps. You can put the substeps up as high as you like, incidentally, and you get slower sims but more fidelity. And there we go. Since I weakened the glue, that piece is falling out, and you can see it's retaining its shape. We get now a little noggin stain over here as well. So this is nice. We have our nicer impact, we have bits staying together, and we can dictate the look of how the wall is going to end up once the car has gone through. So now that I'm happy with that, like we did before, we can select the output node at the bottom here. We can click on Save to Disk, and that's going to write out our simulation to disk. Incidentally, since it's cached already, it's going to just save out that cache for us. If you click this button, Initialize Simulation Ops, it'll actually ignore the cache and just calculate it fresh. That can sometimes be a handy thing. Oh, look, there's the color not displaying correctly. Let's dive inside the wall network again just to get that refreshed properly. Now, to read the cache back from disk, you select your Auto DOP network, turn on Playback Simulation. You can tell it's working because the cache color's gone purple from blue, and we can slide through and check that out. So I'm just going to quickly play blast that, flipbook it, and then we can see the result of that. Let me just pause the video while I do that for you. There you go. I just paused the video for you, so you didn't have to wait for this to load up. If I press play, we'll see the car going nicely through the wall. We can see bits staying together, bits staying up how we wanted. In fact, we have much more directable control over this. Hope you've enjoyed the video, and thank you.